Hi there, it's Matt Heffernan. Welcome back to the Retro Desk. And of course, I'm Matt Heffernan. And today we're going to go back to doing a little bit of hardware. Now, if you saw my last video, it was probably a bit different from what you're used to seeing on my channel. It was a tutorial for Python, which I feel is a very good language for teaching people how to program without any experience whatsoever. And that's what that tutorial is really aimed at. Probably not my normal subscriber or viewer who is probably a little more experienced when it comes to programming, but I think there's a lot of folks out there who would probably benefit from the way that I prefer to teach how programming works. And this is really my opportunity to get right in at the ground level and try to get more people on board with programming, because everybody says you got to learn how to code. Well, now the great thing I think about Python is that you can really do it on any sort of platform, and it's not just like a modern laptop like this one, or over here on the Raspberry Pi 400, which is a super basic ARM computer. You can do Python on even something as simple as this guy. Remember him? This is the LilyGo TTGo VGA32, which is this sort of a little eensy nano retro computer, basically. You can see it has all retro I/O on it. It's got a VGA port and the pair of PS2 mouse ports, mouse and keyboard ports, so you can emulate some really simple things like a VIC-20. This is generally what I use this for, is a ultra portable VIC-20 emulator. That it's just a kind of a neat thing to play with. But basically, it's an ESP32 development board. You can test all sorts of cute things on it, and generally it's for things where you would make use of the VGA output to do things like FabGL. I've gone over that a bit on my channel before, but this time I'm going to just do some more basic ESP32 over a serial port type things. And one of the things we can do, what you might have guessed by now, is Python, specifically MicroPython. So if we go over here to micropython.org, we'll see that MicroPython is a lean and efficient implementation of the Python 3 programming language, blah, 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 blah. And I think the important thing to see here is a small subset of the Python standard library. And it's meant for microcontrollers like the ESP32. Little tiny guys like this that can run Python. So what they have are a bunch of pre-built versions of MicroPython. You do have the source code. It's all open source. And what they have a pre-built for is this guy right here. His cousin, the LilyGo TTGo LoRa 32, which is, you can guess, a LoRa board. It looks like it has a sort of built-in display on it, but the main thing is that it is able to communicate using the LoRa wireless standard and not just the Bluetooth and Wi-Fi, although it has those too. Of course, this guy has Bluetooth and Wi-Fi, or at least it has the Wi-Fi. You know, I've never tried the Bluetooth on this. I think it has Bluetooth. I'm pretty sure it does, but it definitely has Wi-Fi. But we're not going to be using really any of that, but what we are going to use is this, because you can see this guy has a TTGo version of the ESP32, as does this guy. It's the same processor. So the differences in terms of what we'd want to do for MicroPython are just really insignificant. This will work pretty much the same way as this guy. So we can download the firmware specifically for this board that runs MicroPython. But if you want to make your own ESP32 development board, a little small project like that, or something even bigger like the beautiful motherboard for the Commander X16, just an amazing piece of work. If you want to have beautiful PCBs like that, the only place you need to go is PCBWay.com. And of course, beyond those PCBs that you can get for as little as $5 and turn around in about 24 hours, beyond that sort of amazing service, you can do any sort of prototyping that you need, including CNC machining, injection molding, 3D printing, All of that stuff is available to you at PCBWay.com, and just get all that stuff done without having the overhead of some giant warehouse garage with all sorts of expensive equipment in it. Just let the folks at PCBWay take care of that for you and make your dream a reality. So when we download that, what we can do is use the ESP tool, which is this firmware downloader. And here, if we run this, we can see it goes through the process of loading up the firmware. And what we're going to have is MicroPython. So let's take a little look at MicroPython while this is doing its thing. So we can see here there's a nice set of documentation on here, and we can see a little write up here on differences from CPython, which is that reference Python interface. That's the one that pretty much everybody uses that uses Python. And I think the thing that's going to be of really the most importance here are the modules. So it doesn't have all of the modules that you might expect. So if you get a standard Python, just the standard download package that you would get, and it comes with a bunch of modules pre-installed, a lot of these standard Python modules that are created by the Python Foundation. But here you're only getting a subset of those. And so it lists here some of the things. And so what I want to do is, you may have also guessed this, is run my Mandelbrot set benchmark on it. Now, I wrote a Python version. It's in the multi-Mandelbrot repo that I have on GitHub under the modern, and it's mandelbrot.py, and here it is. It's very simple. I'll have a link in the description to that code, and you can go ahead and download that. Now, the first version I made on this, I actually made on my phone because I have a Python IDE actually on my Android phone, which is pretty neat that you can do that. So that was how I tested it, because I didn't have a computer around me when I had the inspiration to do this. So I was able to write this program, and I was using initially the datetime module to do that. But the thing is that datetime is not included with MicroPython, just the regular time library is, because again, as you might also predict, that even though this is a basic ESP32, this guy is going to be too fast to appreciably time. So I had to just kind of reformat to make it that easy, not just to use the modules that come built into MicroPython, but also structure my program in a way that I can copy and paste it into the Python shell, because that's pretty much the only way I have to do it. Is you can't load a file. You just have to use the shell to type things in. But let's see how our okay, so it looks like we went ahead and wrote all of the firmware in. So I can use PuTTY to load up MicroPython, and here it is. So here's that command prompt, the famous Python command prompt right there. And just as I would see it if I did it on my my laptop directly, this of course is using Python right here, and you can see I'm using Python 3.8.10 on this guy. This is saying, hey, I'm TTGo LoRa32. Not really, but it's using MicroPython, and I get that same prompt on there. So I can just type in stuff. I can do print hello Python, and there it is. It works. as you might expect it. But I can't load a file onto it. I can't access GitHub. I can't do any of those things. All I can do is type into there, or I can copy and paste. So I managed to structure my program so that it'd be easy to copy and paste and then time. So I put the whole algorithm and timing inside a function, and then I just call the function as the last bit, and that seems to make everything work okay. So I go ahead and copy all this code, and then I've got it all in there. It's got the time module imported. It created these pixels, which are just basic ASCII characters to represent the different thresholds of the results, and because I don't have colors to work with here, at least not as far as I know. I don't know if this supports anything fancier. I suppose I could make this put out something like an ANSI terminal, but we're not going that deep with this. But here I've defined the function, and now I'm ready to call that function, and let's do it. And look, there's my little plot, and it said the time was about 1/4 of a second. So, not too bad right there, right? Now I can copy and paste the same thing here into this shell, and I run it here directly on my computer, and it's a lot faster. It's just about 7.8 milliseconds. Now, this is, of course, is a 8th gen Core i7. It's not a super new computer. It is vintage 2019, but it is still a pretty fast little guy here running Linux. Now, let's see. Of course, while we're benchmarking Python over here, we already benchmarked the Raspberry Pi with C++. This is a single-threaded Python implementation. So let's see what happens on the Raspberry Pi. The nice thing about the Raspberry Pi is I do have GitHub, and I can just pull this script off the repo, and I can load it up here in Thonny. So if you watch my Python tutorial series, that first video came out last week, and I'm using Thonny for instructional purposes on here, and so here I'm able to load up that same code in Thonny, and then just click the run button, and we'll see how fast it is. All right, so Raspberry Pi 0.14 seconds. So it is a little faster than the ESP32. Now you'll notice that the shell was kind of slow. It was definitely a pregnant pause waiting for each line to print, and I think that's just the slowness specifically of the Thonny IDE. But as you can tell, it had pre-done all of this output and was able to do it in 0.14 seconds. So it's still faster, not quite twice as fast, but significantly faster than our friend here, the ESP32. So that's pretty much all I got there. So I hope you enjoyed this. This was kind of a quick look at the different ways that we can use Python on computers that are new, and other computers that are kind of new but also kind of retro. Now, you can't do Python on something like the Commander X16. I know a lot of folks said, hey, why can't you use Python? Why do you have to use BASIC? Well, there's a reason why these old computers use BASIC. Python, there's a lot going on there, so it's asking a lot of your CPU to do it. And that little 6502, even at 8 megahertz, it just can't keep up with that. So yeah, you have a certain baseline level of power in order to run Python, and a sophisticated enough memory scheme. You've got to be able to deal with a fairly large heap, and 6502 doesn't do heap so much. But yeah, that's it. That's all I got for this guy. So I hope you enjoyed this video. if you really want to support me making videos like this, or like the tutorials, or whatever the content is that you come to my channel for, the easiest and frankly the cheapest thing for you to do is just click that subscribe button and click the bell to be notified when the videos come out. So as soon as they come out, you'll get a little ding. You get to watch my new video. But if you want to help me a little more be able to acquire things like these little toys that you see here, maybe upgrade my computer, you know, get out of 2019, you can support me even more by clicking the join button here on YouTube. And also you could go to Patreon and, like the folks you're going to see on the screen right here, be able to support my channel even more and get early access to my videos ad-free. So I think it's a pretty good deal. All right. So that's it. And I'll talk to you again soon. Bye-bye.